Uh, okay then. Uh, I think it's the right time. I think I can see around 50 candidates. Thank you for respond. We'll start the session. Maybe the students will join later. But before that one, let's have certain some check. I hope you are able to see my screen, right? Hello.
Yes, yes, sir. Yes.
Okay, great. Okay, so let us begin with the revision. Okay, let's try to revise a few things. Then straight away we'll go to um, um, next stage of designing the machine learning model. Okay, so uh, this is what we did in last session. Let me activate my virtual environment. Okay, so activate. Let me come out of this. You also meanwhile try to activate the configure, activate the virtual environment. Okay. Yesterday in yesterday's session, let us try to have the vision. So in under SRC folder, okay, we have created a few folders like how to get the data, and you know very well how the transformation of the data is happening here. So the data was there in the data source. From data source, what we did, we migrated the entire data into process data, and this is the real data. Remember, guys, uh, where all the training is happening using this data that we are doing the training, and this both the data where we have stored in our local system. Not we are not going to push this one to our GitHub repository. And apart from that, we have created the folders. um, we have created the folder in the name called train and test. Then what we did, we started splitting the module. So there are certain lacunas here, there are certain errors, and thanks to the sir that he has given me after modifying the entire code he has given me, so we started running that one. Then what happens, we come across some problem like related to the classes. We had around 8 classes, so I want you to refine these two files. Okay, refining in the sense we need some proper the final script here to arrange the data properly. Okay, so that thing we need to do. See, our main intention here it will be to make the whole process automated. 99.99% we want to make the automations. Okay, that is our intention. Copying and pasting manually कोई भी कर सकता है. Okay, so we want everything to be automated here. That is our main intention. So I'm going with this file to push the data, from a data source to our processed data. And we have seen certain type of mistakes where there students started rectifying those one. Thanks to all of those batch students for helping me out. Okay, and now next one, what we did, we went on designing the model using the file called model train.py file. Okay, and successfully we was able to run this file. Okay, now what happens, since we had given only one epochs, I guess. Okay, so that itself is was taking around 2 hours for me. And I should help we should help thanks Rohit. He has shared the model. Okay, so with the extension .h5, I don't know how much epochs he has taken it. I'm going with the same model today for the deployment purpose. Okay. Now what I have done, I have downloaded that model directly from the WhatsApp account. Okay, just download that model from WhatsApp account, and you can store that model inside the file called models. Okay, so we have here, let's continue now. This is my SRC, and you can see there is a file, I mean folder called models. Under this model, I have kept train.h5 file. But remember, in your case, you just try to train the model. Understood? As soon as after successful completion of training of the model, what happens, automatically that model will come and stored here. There is, that is train.h5 model. Understood? So like that, likewise, I'm just trying to save my time, and again we need to train the model using the MLOps now. Okay, now next, what is today's agenda? Today's agenda will be to train the model along with the MLOps. Okay, so that whatever the parameters records we are getting, that records, all those records will be stored where inside the MLOps. Apart from that, we will try to touch even the evaluation of the model, which is again very important, uh, which is a part of automation testing. Okay, so most of the automation testing we are doing through evaluation.py file. Maybe certain errors will be there here. We need to rectify for all those errors in evaluation.py file. Understood? So apart from that, then what we will do, we will have GitHub actions to make the whole process automated, and we will try to deploy the model using the Streamlit applications. I hope you are clear with today's agenda. If yes means please raise, I mean, give a thumbs up. If no means you can ask the questions. Okay, there will be no theory part today. Straight away we'll go to the programming part. But yesterday, since if you take model.py file, we had taken here threshold, okay, and we have taken the threshold as a softmax function. Yes, Jaish, you have any questions? Jaish, any question, Jaish? Okay, you can drop your hand, please, if no questions. Okay, uh, let me check in the chat. Hold on. Yeah, thank you, Jaish. Now next is, see, in yesterday's session in model train.py file, we had taken the threshold as softmax function, right? This is our threshold, so activation function we have used. Now let us try to explore what is the advantage of using the softmax function. Why we are not going with the other function? For that one, I have created one more. I have just modified this yesterday's PPT just to understand how sort max function is work. Okay, sort max function, it's a mathematical function. Okay, and it will convert all your vector data into real time data, or let's say the vector data, it will convert into probabilistic distribution system. Okay, probabilistic distribution system. Now the question is why we need softmax function. The major, okay, as far as softmax function is concerned, one second. Yeah, software function is concerned. This is widely used for multi-class to solve the multi-class problems. Suppose let's say you have binary, so we can go with other one. Soft class function threshold are used to solve the multi-class classification problem. In our case, since we have how many number of classes? We have four classes. That means this is falling under the category of multi-class label techniques. So that is the reason we are going with the softmax function. And obviously it will convert your largest nothing but the numerical data. First, let's say pixel to numerical data, what you are converting, then it will convert all those data into probabilistic distribution, or let's say probability, and the range of this value will always remain between 0 to 1. Max will be 1 here. Always remember, if you have four classes, this value, I don't know how it is going to calculate, this will be divided into 4. Understood? This is how it works. Now, softmax function, uh, there are certain problems. Okay, the not problem, challenge part also will be there in the softmax function. In softmax function, this is the formula. Okay, so this is a standard formula we use for to calculate the value here. Remember, so exponent value will be the x of I, and summation of ex of I will be there. But when if the value of this one, let's say you are keeping the bit value be 64. Please mute the mic, please. It's a humble request. Okay, so if the bit value is 64, there may be a possibility this can overflow. Okay, there may be a possibility of overflow. That is the reason generally what we do in the layer, we go for the normalization. In normalization, what happens? Let's say you are giving 64, then it will drop down to 32, next 16, 8, like this, it will go. There may be a possibility of overflow in the softmax function, but it works efficiently when the bit value is 32 or lesser than that. If it is more than that one, means there will be a possibility of what overflow. Now, what is a uh, solution for this in probabilistic distribution, or let's say in the world of probability? So what do you do? Okay, so just modify this softmax function with ex of I minus m. Understood? Ex of minus 1, that is a mathematical equivalent numerical stability. Generally what we do to have the during the computation to have the numerical stability, what we do, we try to minus with the one value. Suppose let's say n minus 1 we have, exponential value will be there. So exponential value minus m value, when value can vary here, you can keep, let's say m value is minus 1. So in that case, suppose let's say 32, it's exceeding more than 32. So what we will do, we'll try to have minus 1 there, so that it will come to the range. So the problem of this overflow can be avoided. Understood? So this challenge are there. This can be you can take this one as a mini projects as well. How to do this using mathematical functions? You can approach your mathematical department and ask, discuss with them how we can, how these formulas are working. So based on that one, you can design your Python program for to overcome from this type of a problem. And apart from this, apart from this, yeah, apart from softmax function, we have other functions as well. Uh, for activation function, like we have segment, we have relu, and we have tanh. Okay, so these are the widely used the activation function in the world of deep learning. Now let us try to have the range of this one, how the range of the uh, answers will be. In softmax function, the range will be 0 to 1. In segment also 0 to 1. Relu we can go up to infinity. Okay, 0 to infinity. Now, if it is infinity, it is not a good solution or to call a relu at the output layer. Suppose let's say this is your input, this is your input, then you will be having hidden layers, then you will be, yeah, then you will be having output layers. So in that case, you are starting the training from 0 and it will go up to infinity. So that means this is a not a good solution, right choice to use relu in the output layer. Remember, where I can use this one, definitely I can use this relu function in between input and output, which is nothing but a hidden layer. You can use it. And for input and output, either you can go with the segmoid function. Okay, segmoid you can use segmoid, or you can go with the softmax function or tanh. Now, apart from we have another activation function called tanh function. Okay, and this is this also you can, the range of this one it will be minus 1 to comma 1. Okay, so here what happened, let's say you want to do back propagation. In that case, you are going back one step back, so that means minus 1 can be used here as well as tanh functions are concerned. Now you have brief understanding which activation functions to be to use in which type of use cases. Now let's say the use cases. If it is multi-class classification, go with softmax. If it is binary classification, then you go with segmoid. If it is relu, okay, and relu and tanh can be used in the hidden layers. So that means pretty straightforward. In input, you can use segmoid activation function. Okay, hidden layers, you go with relu. Most of the expert do like this. And for output level layer, you can go with the softmax. Like this is also possible to I have the activations function. Understood? Now, some of the output, definitely in the case of softmax function, if you add all the values of all the four labels or multiple labels, the sum of the values, the sum of the result should be 1. It should not exceed more than 1. If it is exceeding more than 1, what is the condition? Exceeding more than 1 means there is a problem of overfitting or what outer fitting, generally we say. Okay, so there may be a problem in the model itself. Usually it will not go more than 1. It will remain lesser than 1 if it is a model is good. Otherwise, if it is going more than 1 means there is something wrong in the what your model itself. Okay, this is what I wanted to explain that was skipped. Um, uh, I didn't cover that one in the last session. So I thought of covering in today's session regarding softmax. And today also we are using softmax function uh, in MLOps orchestrations. Okay, let's move forward. Let me open my, yeah, any question. If you have any question, please let me know, guys. Any questions? Any questions? Okay, let's move forward now. I will not explain again what is MLflow. Last session I had taken almost 1 hour to explain MLflow. Okay, so theory part will not be there. Straight away we'll go to the practical part. But in MLflow, last time when we was using it was for regression. Okay, regression technique or binary classification we used. Okay, now what we will do, we will use the MLflow for deep learning. Let's say what MLflow says, how to handle the deep learning in MLflow. Okay, so what I will do, let me type MLflow official document. Okay, official. Let's go to the official site, or else straight away I'll use MLflow
हॅलो
deep learning. Yes. Hello.
काही नाही फक्त इंट्रोडक्शन झालं म्हणजे काल काल काय काय झालं ते सांगितलं आणि कोणतं फंक्शन कसं ते
Sir, you are mute. Your mic is off.
Okay, so I'm audible now. Oh my God.
Yes, yes,
Hello. Okay, so
yes.
now, okay, so are I hope you are able to understand, you got the concept of softmax. Hello, hello.
Yes, sir.
Okay, now let's move on to MLflow. Okay, so in MLflow, how to handle the deep learning concepts in MLflow. Since I said in the deep learning, what happens, you will be having huge amount of a data, and the performance also we have to keep at certain levels. And how all these parameters are tracked by the MLflow, that is very important. Now, as far as MLflow is concerned, it supports for PyTorch, Keras, and TensorFlow. And apart from this, how we can create this support for all these three. So there is no issue, is compatible. Now, how we can check the parameters here? So based upon the loss and accuracy, we can check the status of or health of your machine learning model. There are two options are available, okay, to check the loss and accuracy. Either you can go with learning rate, LR. Okay, so you can set certain learning rate here in the model. Let's say 10 to the power of -3, 10 to the power of so and so. Okay, learning rate is also, but real time data also you can process it. And apart from this, if you have batch size of a data, it also support for batch size of a data. Suppose let's say you have designed a premature model. Tomorrow you want to add some more data. In that cases, you can go with the batch size technique as well. Understood? And what makes this ML flow different from deep learning, different from machine learning? So you will be having what in deep learning, you will be having data in terms of vectors, where you will be having the
Huh?
data
Huh?
in terms of weight and size. Wait and send. It's an humble request. If you have any questions at that time, you can unmute and ask, or else it's please don't uh, uh, unmute unnecessarily. It is really disturbing the classes since we have 80 plus students here. Okay, so it's very hard to control, So it's an humble request. Don't unmute and unnecessarily discuss. Okay, let's move forward. Why ML flow for deep learning? Okay, so it supports all the three components. You can track the models even though it is you have a huge amount of a data there. You can register the models also, and you can deployment. When the model is in the deployment, you can perform all the REST API. Okay, so endpoints you can create and you can deploy and you can check the status of the models in the MLflow. Understood? So uh, how it will look like, so you are familiar with this one, so you can have the same graphs even for the deep learning as well. Okay, now apart from this, this is supporting for all Keras, you have TensorFlow, PyTorch, Hugging Face, etc. Okay, and let's go for Python since we are designing of uh, the project using the Python. Let's see how to track that one. If you go to so all the options are available. You can check this one by one. Let me go to Keras. Okay, so if you go to MLflow Keras, you can see the code here, TF Keras. Okay, so this is the path we will be using to track our machine learning models. And certain we have the matrices like stop epochs. These are the extra matrices which is offered by the MLflow, uh, through which we can uh, stop or control the complete transactions of your data in deep learning. Okay, if you want to have an early stopping, we have the callback function. Callback function is supported by the MLflow as well. Okay, and number of epochs, long every epochs. Let's say you want to check the status of every epochs, you can have it. Okay, log models if true condition and false conditions. So that is already we have designed in params.yaml file. What happens if it is false? The train model will not get trained. If it is true, the model will get trained. Understood? So that can be done here. Likewise, we have all the options which are available for us while designing the model. Save best only. Now this is a very important. Save best only we have. Okay, so that means which training or epochs is having the best accuracy, that only will be considered by the checkpoint. Already we have created the checkpoint in our MLOps model training system. And apart from this, okay, why I have opened this standard, I mean official site means how to call MLOps. Okay, so how to call the MLOps? See, this is the library system we will be using to call an MLOps. Okay, MLflow.keras callback. Then we have callback system. You give the epochs, how many number of epochs already we have given in the parameters, and steps. Okay, so log every steps. If you are giving none, so that means what happens? All the steps it will record and it will track, and all those records will be saved inside the artifacts. Okay, and we have obviously we have the sample code here, but we are not going to use this sample code. We will have our own code to run the MLOps. But take home from this official site is how to call MLOps in deep learning. So have a look on this. This is a code generally we use to call an MLOps in deep learning. We will be having the method called start run. Okay, we will be using start run from the ML flow. So it will start the tracking of the model. Okay, and all the records will be stored in the artifacts. Rest of the things will remain same. This will remain same. Okay, so how we have fitted the model, in the same way we are going to fit the model even in MLflow. There is no much difference between yesterday's last file as well as today we are going to define the file. Understood? And we have to call one condition called MLflow Keras MLflow callback conditions we will be using. Understand? And this is kind of a repetitive task of how the number of epochs are increasing. In the same way we will be that will keep on repeating the task. And apart from this, how to load the model? This syntax, this is a subfold files. This can be a method, remember. Okay, under load we have Keras model, and then you give the parameters to load the models. Okay, so this is how we will be using. One more thing I just wanted to show you regarding about the S3 bucket. It is not like, see, it's not like you can store all the data in your local machine. Data is scattered around the world. Okay, so we cannot predict from where the data is coming up. Understood? So it can be a globalized data or it can be a local data. So in that case, if it is a globalized data, so we need to pull that data from the external world. Suppose let's say the data is in S3 bucket, so we need to pull that one. And now our MLflow also support to pull the data from the external world also. So you can make use of the method called model URI. Okay, so just try to call this model URI. In params.yaml file, you give the location or the link of that the data where it is residing, and that you call that one. So immediately it will start loading. MLflow will start loading the data from the external world. That option is also available. Okay, so yeah. Next, yeah. So I was searching for 1 second. This is not required, I guess, and I'll share this link. You can go through the official documents. They have explained in a very simple way, okay, how you can design a model using orchestrate the model using the MLflow. But same technique also we are going to use in our session also, but the approach will be different here since we are going to do everything as an automation. So obviously in automation what happened, so we have created multiple segments, and whenever in future if you require any modification, you can do directly the modification by hitting on that specific part or the segments. So our task will be easy here. Okay, so let's move forward then. So this is the simple theory I thought of covering in today's session. So instead of mm, I always focus on the theory, I mean, practical part rather than spending more time on the theory. Okay, so this is my repository. I hope everyone are having this repository link. So the whatever the modification we are doing, so all those modification will be we are storing here itself. Understood? Let's move forward. Now, our task is in today's session in the first phase. Our task is to run the model with MLOps. Okay, so with MLOps, we are going to run it. So for that one, since you know, before running any MLOps programs, make sure that server is activated. We need to activate the server here. How to activate the server? First and foremost, you go to requirement.txt file. In requirement.txt file, um, we need to install one dependency in the name called MLFlow. Okay, so let's try to run that one. Let's try to install that dependency MLflow. How to do that one? Pip install -r requirement.txt. Run it. This will take time. Have patience. I'm not going to push this one. You can do it directly. Go to requirement.txt and run that command. Okay, this will take time. Have patience. डीप लर्निंग में जब काम करते हो तो पक्का तुम्हें पेशेंस चाहिए because it takes a lot of time, trust me. MLflow, let this get finished, then we'll go for to design. We'll configure the our entire project for MLflow. Come on, yes, you can see now our MLflow library is activated now. Now, most important part. Now, after activating the library, next is what? Can someone tell me? Next what? Next, we need to create one artifacts directory. Okay, so let's try to create an artifact directory. Let me go to params.yaml file. You can see here inside. Okay, so you can see here inside MLflow config, we have one artifacts directory. So this is going to be my artifacts directory where all my records related to orchestrations are stored. So what I will do, let me create one directory in the name called mkdir artifacts. Run it. So you can see on the left corner, there is a folder in the name called, okay, so there is a folder called artifacts now. Perfect. Okay, so make sure that you create one artifact folder. Now, how to run the Now let us try to run the MLflow server. How to run the server? See, there are two options to run the server. Directly you can go MLflow UI. Directly you can write this command MLflow UI. So the moment when you hit on this command, so what happens? Your MLflow server will get activated. In the same way, suppose let's say you want to go with all the specific information. Let's say, okay, so what you can do is you can run MLflow server hyphen backend hyphen backend. Okay, store URI store hyphen URI. Okay, backend store hyphen URI. Next, since we will be using SQLite as my local database, SQLite, SQLite I'll use. Let us try to give some name. Let's say I'll try to give the name as AI. Let's say MLflow DB. Default, I will give the name as the name of the database B MLflow DB I have given. Understood. Now, obviously, artifacts, we need all the data I want to store in artifacts. How I can do that one? Hyphen default. There are two hyphens there. Okay, default. Next, artifacts. Artifacts. Or no, sorry. Artifact hyphen root. Okay, hyphen root you can use and give the name of that artifact. I think this is the artifact name under artifacts. And what is the host here? Since we will be hosting this one in local machine, so we will use the IP address 127.0.0.1 and the port number obviously it is 5000. Okay, so this is also this is how you can run your MLflow server. Let me copy and paste in chat box so that you can refer later to activate the server. Okay? So you can check in the chat box. It is available now. Now let us try to run this one. Let's try to run. If everything is okay, means it should activate our server. Hold on. So wait, yeah, I think it is activating. Hold on. Yeah, it got activated. Can you see this one, participants? Hello, hello, hello. Can I get a confirmation, please? Okay, so it got activated now. You can see the interesting point here is all the data will come and reside here inside the artifacts. And you can see there is one database in the name called mlflow.db. Okay, so database is also got created. Now, if you want to access this, just run this link in your web browser. You can see the complete MLflow server for the orchestration. Okay. Now you can see the complete server is available. I don't want to dig again. I have covered all these things in session 1. Understood how exactly this works. We have experiment and models, all the models and come and reside here. And you can version all those models directly from here. We will be having, this is the main dashboard where you can see all the number of models with respect to the parameters. If you want to customize your parameters, you can go here and you can customize all the parameters. We'll do that one once the model is ready. Next, chat view. Okay, so if you want to have, let's say, graphical presentations, you can use this graphical presentation, especially this evaluation of the model are there. No, all those evaluation of the model and error findings can be we can do using the MLflow orchestration. Okay, now my server is up and running now. Now it's time to create my model. Let's try to create a model. So right now what I will do, so I'll open one more terminals. Let that server run, okay, in the backend. So I'm going to use one more PowerShell, that one more terminal. You also from your end try to activate one more new terminal. Okay, so and let's try to activate this. Okay, activate scripts, activate .ps1. Done. Next, yes, done. Fine. So my activation done. Next, what I will do is let's try to write our file now, script. Now, since we have model.py train, okay, so there are no much Same scripts will remain same, but we will be adding the flavor of MLflow here. So what I will do, I'll create one more file in the name called uh, model. Okay, model trained with the MLflow.py. You can assign any name, you can give any name here. There is no restriction that you have to give the same name. Okay. Now next, I hope you have created that file. Please let me know after completion. I'll give you 1 minute. If you have created, please let me know so that I can move forward. You can give a thumbs up, please. If done, please give the thumbs up. Is that completed? Just create artifacts, then run that command and create one file in the name called mlflow.py. If done, please let me know. You can give a thumbs up so that I can move forward. Is that completed? Participants? Hello. Hello. Are you there? Hello. Is that completed?
Yes, sir. Yes, sir. You
Yes,
can move forward.
Rohit. Yeah, let's move forward. See, if now I'm not getting any response from your end, I'm not going to share the recording session. Trust me. I will not share the recording session. If I get respond properly, then only I will think of sharing the recording sessions so that you can refer it. Don't keep in mind that चलो यार recording session कैसे भी मिलने वाला है. We'll practice that one. Why to attend the sessions? Don't do that one. ठीक है? Next, let's work on model now. Okay, let's work on model. How to model train the model using the ML flow. So first and foremost, मैं क्या करूँगा? So let's take some smart move here. First and foremost, see, I need all those dependencies. Let me copy and paste all those dependencies from model.py file. Okay, so let's try to take all this dependencies. Copy and paste it here. Fine, copy and paste here. So I have copied all those things and pasted here. So where we will be having numpy, keras layers, dense, etc. All these things we required. And apart from this, we required MLflow. Okay, so required MLflow. So import MLflow. Okay, import MLflow. Now, apart from this, apart from MLflow, we required one more called URL lib. Okay, from URL lib. So I'm going to a URL lib parser. Okay, so import URL parser here. If you want, you can import mlflow.keras, which is the latest version I can say. Okay, which support if you, since we are working on the Keras solution, Keras library for the deep learning, it's better to import even the MLflow Keras as well. Okay, now next what? Can someone tell me, please? Next, copy your main file. Okay, let's try to copy the main file. Let me go to model again. Okay, let me go to model again. Just copy this one. Fine. So I'm going to copy this and paste it here. Fine. Now this time what I will do, I'll just try to replace this one with train model MLflow. Okay. This is going to be my definition now. Okay. Now it's time to work on now MLflow. techniques. Let's try. So the script will remain same. The only thing is we will be adding the flavors of ML flow here. So rather than storing or keeping all the things in local system, we will be storing everything in our ML flow server. First and foremost, let's try to create a definition. Define. This is my definition name. Okay, let's have config file. Config file. Okay, config file done. Now apart from this, we have obviously config. Uh, config. Next, I think it is get data. No, so get data we are using. Get data is also done. Similarly, what I will do, I'll try to copy those things from model now here directly. Say we have this one. So this is for train configuration, right? So let's try to copy this one and paste it here. Let me cross verify. This is for the training. So we are starting the training, new training we are starting right now. Okay. Now next, after that, let's try to post, copy and paste all this configuration. We did it in the model.train.py file. So these are the configuration. No, I hope this is working fine. Yesterday we spent a lot of time, maybe around 40 to 1 hour to rectify the errors, right? So I'm going to use the same thing. Let copy this. Okay, copy if from the if train and paste it here. Okay, so slowly, when you start practicing, na, so you will understand how MLflow works and how we design the complete environment to deal with orchestration of the model. Now, uh, please again you cross verify if any errors here. Please let me know, students. If any errors here, please let me know. Again, epochs is okay. Model path already we have given. Okay, just take a look here. I'll give you 1 minute again. Then we will proceed for ML flow orchestration. ठीक है? Any questions? Any questions? Hello.
No, sir.
Any question? Okay,
Hello,
let's
no, sir.
move forward. Okay, so we did some. I just wanted to give some time. If any further error means it will help. We can save a lot of time later while executing this problem. I mean, uh, model. Sorry, the script. Next, we have same thing. What we have, it's time to call our RESTnet model. Okay, so I'll call this RESTnet model. If you want, you can print the batches. Let's call this RESTnet model. ठीक है? Same thing. Uh, See how easy it is to integrate with MLflow. ठीक है? So I'm just copying and pasting stage by stage. I'm explaining. Okay, VGG 19. So these are the parameter for, sorry, VGG 16. These are the parameters, and I want you to try with the VGG 19 as well as CNN as well. Okay. Now apart from this, yeah. So yesterday we have completed this. Next we have this one, flatten image sizes, etc. So let us try to copy and paste this as well. Okay, so copy and paste this as well. Fine. Let's make sure that you align it properly. These for the flatten images. Okay, prediction dense images we have taken. Softmax function is nothing but our activation function, and we will be using Keras pre-processing to pre-process the models here, and we are storing all the whatever the prediction dense layers values are getting. I'm fetching that one and I'm storing everything in the mod will have our actual model values, and just understood. Next, we are setting the images. Okay, so it goes same even in model generation. Sorry, uh, even during ML flow orchestration. And apart from this, next after imaging, then comes your compilation. Okay, so let's try to compile this. Yesterday we did this one. Copy and paste. It's so easy, no? Okay, copy and paste it. Next, apart from this, we have what training generation, train gen. Copy this and paste it. This will remain same. Train and gen. Okay, understand. I just try to understand which part ML flow is taking here. Okay, for orchestration. Next, this part is also same. Test generation is also same. Okay, rescaling. Apart from this, this also remains what same here. Okay, this part is also remains same. Let me copy this one and paste it here. Okay, so I'll please take care of alignment while copying and pasting the result. Understood? So here, after this, what is there? What is the next stage, participants? Okay, so you know this one, train, testing, we did all this one, training and testing, everything is taking place where? Inside our local machine itself. After this, what? After test set, after test, what is there? After test, we have the history, right? Yes or no? Participants? Hello?
Yes, sir.
Hello? Okay, we have the history, and this history is having the complete values, you know, values of our the model. Okay, now since the moment when you run this one, what happens? All those values, what we have done, all these values we are storing inside a report folder. If you go here, if you go to reports, so inside this one, we are storing all those things. Understood? And now I don't want to store all those orchestration. Okay, so whatever the values we have, which we will be using for orchestration purpose, I don't want to store this one in reports. Instead, I want to store everything in our MLflow orchestration or a server. Understood? So here, what we'll do, this is where your MLflow uh, activation or it will get triggered. Okay, so let me go to again SRC. So what I will do, let me go to my file now. Okay, so train ML flow. Now here what I will do, I'll give some comments here. So start of ML flow, start of ML flow. Okay, start of the ML flow. Next, let's try to uh, activate our ML flow now. Now next, first and foremost, history, whatever the history values are there, all those values I'm going to take inside my ML flow server. Let's try to create one let's try to create one variable in the name called MLflow config. Okay, let's try to config this one. Config means we have we did certain configuration in params.yaml file. I think if I go to uh, params.yaml file, where is my params.yaml file? Come on, where is my params.yaml file? Yeah, this is my params.yaml file, and this is my configuration, right? So copy this one, go to your model, not this one. Now I'll get confused. Okay, so let me delete this. So this is my model and paste it here. So that means whatever the servers I have activated, all those things I want to keep it in. I have kept all those things inside my MLflow config. First and foremost, we need to activate our server. Okay, so let the server activate, and our server is in the local machine which is running in the local host now. So what I will do, I'll create one simple variable here in the name called uh, remote server URI. Okay, remote server URI. Next, ML config. Inside this ML config, so we have okay, we have our remote server URI. Let's go to params.yaml file. Hold on, let me delete this. Okay, so evaluation also I don't required. DB is also not required. Where is my params? Yeah, params.yaml file. And inside this one, we have MLflow URI, server URI. What is my server URI? If I go to params.ur, okay, so server URI. This is not remote server URI. Copy and paste this remote server URI here. ठीक है? Done? Now let's move forward. After remote server URI, now I have the server now. Server is activated. I'm going to link this. Now it's time to okay call that remote server URI in MLflow servers. How to do that one? there is always, remember, whatever the commands are there of MLflow, it always starts with MLflow keyword. Okay, so I'll call MLflow. Now I have to consider this server as an object inside my MLflow server. For that one, there is a method called set tracking URI. This is an inbuilt method offered by MLflow. Set tracking URI, and this you can consider it as an object. This is going to be my object. Call that object as a parameter here. Understood? Okay, so it will set the URI. Now, apart from this, once the tracking URI is confirmed, we need to mention all those labels, like what is the name of your server. Next, we need to create a folders, etc. We need to store whatever the data is stored in the artifacts, that I have to put it in where my MLflow server URI. ठीक है, चलो let's do that one. After setting the track, it's time to set the experiment. MLflow. Okay, next we have set experiment. Set experiment. And what is the, can someone tell me what is the name of my experiment? So MLflow config. Okay, MLflow, this is how we call, remember, from the params.yaml file. Understood? MLflow config. What is my experiment name? Let's go to params.yaml file. Experiment name is deep learning. Okay, VGG19. Just copy that attribute. Go here again to the file and paste it here. Done. Fine. My experiment name is successfully, I'm now able to trigger that one. Now it's time to run my server. Okay, we need to run the server. To run the server, what I will do, I'll make use of one syntax here with statement. And to run the server, we have the method called MLflow start. Since I was explaining this one in official document, so you can make use of the method called start run. Understood? Start run. Then after that, you can start giving the parameters. What are the things you want to run from your from the deep learning? Okay. So once start run is there, now what I will do, I'll call my history now, history part. Where is my history part? Again, let's make it simple and smart here. Again, I'll go to train, and this is my history part, right? Participants. Hello. Hello. Bolo bhai. Okay, so this is the
Yes, sir.
history part. Yeah, history part. See, मैं कैसे कर रहा हूँ, just थोड़ा स्मार्टनेस को देखो, वो कैसे थोड़े मॉडिफिकेशन, स्लाइट मॉडिफिकेशंस कर रहा हूँ, और मैं MLflow ऑर्केस्ट्रेशन में मेरा मॉडल चला रहा हूँ. इट्स वेरी सिंपल. और कॉर्पोरेट क्या करता है, अरे बाप रे, नया कुछ सिस्टम आया विच इज न्यू, तो स्टूडेंट्स को पूरे, द पीपल हु आर वर्किंग इन आईटी सेक्टर, सबको कंफ्यूज करा देते हैं. ओके, सो आपको कंफ्यूज नहीं होना है, और थोड़ा ओवर कॉन्फिडेंस भी नहीं होना है. ओके, और एक्साइटमेंट भी नहीं रहना है. सो उसको स्मार्टली हैंडल करो. कैसे करना है, जस्ट सी हाउ आई एम प्रोग्रामिंग द प्रोग्राम्स. जो मैंने प्रीवियस स्क्रिप्ट में लिखा था सेम है. देयर इज नो मच डिफरेंट. द ओनली थिंग इज न्यू, जब कुछ प्लेटफॉर्म आता है तो उसको सिर्फ इंटीग्रेट करना रहता है बस. ओके, सो हिस्ट्री फिट ट्रेन सेट आई एम यूजिंग. ओके, नाउ लेट अस ट्राई टू या हिस्ट्री तो आ गए यहाँ पे. नाउ whatever the parameters are there, we need to call all those parameters in MLflow server. ठीक है. So train loss, I'll use first train loss since I was discussing about train loss. Okay, so how I can get that train loss? Under history we have whatever history देगा मुझे, train loss भी देगा यहाँ पे definitely. Okay, so I'm calling that train loss. I'm feeding that one to my server now. Already server is up and running now. Okay, मैं बोलूँगा सर्वर को, ओके ट्रेन लॉस भी आप ले लो, -1 इंडेक्स -1 से स्टार्ट करूंगा मैं. ओके, नेक्स्ट, apart from this, do we require, okay, validation loss also I want. How I can do validation loss? Can someone tell me how to do validation loss? Huh? Let's try to create one more variable in the name called validation loss. Okay, so validation loss भी मेरे पास history में रहेगा, and this is the variable where validation loss can be, we can track the validation loss. Let's see if any errors are there, means let's try to rectify that. Okay, and apart from this, what about the most important part here is my accuracy, right? So no participants. Hello. Hello.
Yes, sir.
Hello. Okay. Accuracy is very important. Okay. So loss or accuracy, based on the loss and accuracy, we can track the model. Okay, so that is model ऐसा चल रहा है, model is flexible, we can go with these models. Okay, those things we can done through the accuracy, that we will even you can use accuracy also. I'll show you how to do that one. Now first let us focus on our parameters. What are the parameters we will be using? Maybe you can use the parameters वहां पे जब हम लोग when we started our first phase, there we had used the parameters like RMSE value, RAE value, and F1 score value we have used. But here we have the parameters like epochs, okay, loss function, matrix functions, etc. are there. So that those things we are going to use here. Now how we can do that one? MLflow. Okay, MLflow log param. There is a method called log param. Use log param. Okay, log param, and we have epochs. Let's say let's start with the epochs. I have used epochs 1 here. Okay, अभी तुम्हें क्या करना पड़ेगा? We cannot change the values of RMSE RAE value. तुम्हें when you want to have multiple versions of your model, just go to params and change the epochs. कहाँ है epochs? यहाँ पे. Okay, so change the epochs. First you do 1, 2, 3 like this for every number of epochs, consecutive epochs, you will be having the versions of the model. ठीक है. Now trainable, let me put this one under false. Okay, so मैं यहाँ पे false में रख देता हूँ यहाँ पे, so that it should not automatically start training. Now let's go again to this is going to be my one parameter. And apart from this, can anyone suggest which parameters I can use? I'll use MLflow. uh, MLflow, what I will do, log param, I'll use log param, and I'll go with the loss. Loss कितना हुआ batches में? Okay, normalization जब आप करते हो, so how much loss we got, that I want to record it. Based on this loss, we will be able to track the model as well. Understood? And apart from this, validation loss. Similarly, we will try to check the validation loss also. MLflow. Okay, log param. Next, you can have validation loss. Validation loss I will call, and validation loss directly. Done. Any questions, participant? Any questions here? Bolo bhai, any questions?
Sir, can we
No,
have
sir.
for accuracy as well?
That's a good question again. Accuracy. So what I will do, MLflow. Okay, MLflow log params. Next we have accuracy के लिए we have, I think, train accuracy. Okay, so let's have train accuracy. Train accuracy. This is nothing but ये label मैं दे रहा हूँ accuracy. And we have train accuracy. Okay, train accuracy. I think we have given train accuracy. Fine. I think we need to check this one. Train accuracy or train अगर ये variable रहेगा तो definitely train accuracy. Let's see this one. ठीक है, train accuracy रहेगा. Fine. And apart from this, any other parameter you want to add? Any other parameters? We have validation accuracy, right? Yeah. So train accuracy नहीं है sir. We are using validation accuracy here. Okay. तो यहाँ पे log params. So I can make use of val accuracy. Okay, val accuracy. Okay, so I can make use of validation accuracy here. Val accuracy भी नहीं है, I think. Okay, we need to work on that one. Let's try to do that. Any other log parameters you want to add here, participants? Hello. Matrices. What about matrix? We have matrix, no? MLflow dot log params. Okay, now here we have matrix. So matrix, understood. Optimizers we have. We will go with 5 labels now. Okay, agar future may if we want to add more modify, we can do it further. These are the parameters we will be using to track our the model. apart from this we need to give the artifacts. Okay, data हमें artifacts से fetch करना है. How I can do that one? Since we have created artifacts here. ठीक है. So let's try to fetch the data from the artifacts. How we can do that one? I'll make use of I'll create one variable in the name called tracking URI type store. Okay, tracking URI type store. ठीक है. Type store, and when you want to fetch anything from external sources, यहाँ पे artifacts ये external sources है, external source है for my server. Okay, if you go to server, this is my server. Understood? मुझे क्या करना है, जो भी data artifacts में है, I want to push that data to my server now. For that one, we make use of the method called URL parser. Okay, so URL parser methods are used, and I'm saying the MLFlow, MLFlow, use this method get tracking URI. Okay, general syntax to get all the data from the artifacts. Okay, so from the artifacts, it's not tracking URI store. This should be not tracking, this should be get artifacts. Let me try whether that method is available or not. Get artifacts. Yeah, get artifact URI, this method. Okay, so we will be using this method. We are saying MLFlow. MLFlow is saying to Python, okay, Python, go use this method, go to that artifact and fetch me all the data, and so that I can store that one where inside my MLFlow server. And who is going to do this one? This is a mediator. URL parser will be the mediator, and it is going to store everything as an object inside the object called tracking URL type store. Okay, so let's move forward after this. Okay, now what I will do, let's try to put the condition. Yeah, since you are able to fetch all the data, first I want to check the condition whether those data is already available in the server or not. If it is not there, means then you update the MLFlow server. Like that we have to do it. For that one, I will call one if condition tracking URI. Okay, if that file is not exist. Okay, so hold down. If that file is not exist, okay, if that file is not exist, that file, whatever the file is not exist, then what I will do, I will tell the MLFlow to create it or else update it. That's it. Now first and foremost, remember हमने first phase में जो MLFlow regression किया था, there we had py function. Okay, py function we used to track all the data. But in the case of deep learning, we will be using Keras.log model. Okay, so Keras function we will be using here. MLFlow.Keras. Okay, MLFlow.Keras. Next, we have there is a function called to log the model, that is log model. Understood? Now, can someone tell me where is my model is stored? Model is stored inside mod, no? Yes or no, participants? This is where my model is stored, right? Hello, hello, hello.
Yes, sir. Yes.
Yes. Okay, so this is where the model is stored. So I'm going to call and paste it here. Okay, mod. Next, let's try to give the model. Okay, so where exactly my model is available? This is the directory where my model is available, right? Okay, this is where my model is available, and my registered model name is which one? Registered model name. Now I want to register model name. How I can do that one? I have already given the registered model name in MLflow config. Okay, MLflow config. ठीक है, MLflow config. And inside MLflow config, if you go to params.yaml file, there I have given the name of my model. Let's go to params.yaml file. Where is params.yaml file? This is my params.yaml file, and this is my registered model name. Okay, deep learning model. ठीक है, चलो next let's go to MLflow and paste it here. ठीक है, done. Now next else. Okay, you can give any other parameters also. So I think it's better, let's have few parameters now, right now. Next else. Okay, else what? put the condition. Okay, else if model is there means you all the updated is there means you run that same version of the model. That's it. Okay, MLflow dot Keras, MLflow dot Keras log models, and this is the current version of the model which is in the production area. Okay, and then give the models. That's it. This is it, guys. Okay, now else since it is a train, we are putting everything in the condition. No, if you go back up, yeah, see here, if this is true then only this will work, otherwise no. So else what I will do, else again, this is the outer else loop. Okay, else I hope it is correct. Okay, the model is not trainable. That's it. Model is not trainable. Done. Okay. So rest of the things will remain. So I think we have the main functions also. So what I will do, I'll push this code first to repository. Just update from your end. Next, we will try to run this in the MLflow orchestration. Okay. Any question? Any question, participants? Any questions?
Sir, actually, normally when we talk about deep learning algorithms, we
Mm-hmm.
talk about learning rate. So we
Ah,
didn't much about learning rate yesterday, and we did not take into account in our program as well. So now
exactly.
in the log param, can we list that learning rate as a parameter?
Obvious. Yes, we can give that in the log file learning rate also, sir. See here what is happening. Okay, in VGG 19, okay, we have already default learning rate here.
Yes,
ठीक
sir.
है,
Yes, sir.
transfer learning में क्या होता है, default already learning rate will be there. Okay,
Yeah, yeah.
and if you want you can give the learning rate in the parameter when you are designing the model here itself. Okay,
Like that.
या यहाँ पे पैरामीटर में आप दे सकते हो, that is possible. We will do that one, sir. That is a good question. Learning rate,
Okay.
the thing is learning rate जब आप देते हो उसमें I mean it is an exponential values.
Yes,
Okay,
sir. Right.
exponential value, there is a formula called r to the power of e minus 1. Okay, so yeah, e minus 1. The question is manually the value of e we cannot decide properly, sir.
Right,
Okay,
sir.
e
That's why
value. Okay, yeah.
different
If it
value
is,
we
yeah, if it is small, if it is a small increase or maximum, थोड़ा अगर ज़्यादा देंगे हम लोग e value,
Mhm, mhm.
that will take days together to complete the training.
Yeah, got
Understood?
it.
So got it
Thank
now.
you.
So
Thank
yeah, so what generally we do, let the machine itself will decide learning how much learning rate they want.
you. Okay, fine, sir.
Okay, so like this we do. Since it is a base now, deep learning, so learning rate हम लोग नहीं दे. But in the case of NLP, BERT algorithm में we generally give even the learning rate as well.
Okay,
Okay,
fine.
okay. So we will explore that one. We will explore
Okay.
that. Okay, let me push participants. You have any questions, participants? Hello, hello, hello. Any questions, participants? Okay, so I'll push this one from my end. पहले मैं push कर लेता हूँ ये. Okay, so that you can update in your repository. Then we will try to run this one. Believe me, this will take time. Meanwhile, in the backend, let this model get trained. We will work on the front end as well as the DevSecOps concept. Okay, git commit. So since hyphen m. Next, we have what this, since it is a day 2 and my first commit. Okay, so it got executed. Git push hyphen u origin main. Done. So just check whether the code is available in repository or not, please. Okay, I think, yeah. MB, come on, writing objects takes times. Hold on. Okay. Yes, because model itself is 50 MB. That was the reason it was taking time. Okay, so now the model is also available along with the script. Just let me cross verify from my end. Okay, and if I refresh this, I think that code should be available now. Yes, the code is available. I'll give you 2 minutes. Please copy and paste and let's try to run together. ठीक है? So 2 minutes. Meanwhile, if you have any questions, please let me know.
Hello, sir.
Yes, sir.
Sir, just one this one suggestion is there, sir. Like
Uh-huh.
at the end, when you conclude the session, say
Mm-hmm.
before half an hour,
Mm.
just I would like you to summarize the this one. Say when you adopt a ML algorithm and how the flow will be there, complete flow, and when you
Yes,
adopt deep learning algorithm, how the flow will be there. So now
exactly.
whatever you have done, just in a brief 10 to 20 minutes,
Definitely.
you
I
can
was
just
I,
summarize
I
so
was
that
planning
we
for that
can.
one, sir.
Yes, sir. Okay, sir.
Yeah,
Thank you, sir.
I'll
Okay,
do that one. Don't worry. Yeah.
thank you, sir.
So I hope you have copied. Can I get a thumbs up, please, students, if it is completed? Can I get a thumbs up? Hello. Yes, Rishabh. Rishabh, thank you so much. Anybody? And at least I need 5 thumbs up today, please. One thumbs up from Rishabh. Aditya, thank you, Aditya. Yes, 2 thumbs up. Yeah. Anybody else? Anybody completed? Hello. Hello. Okay. I hope I don't know what you guys are doing from the other end. Uh, you are practicing or not? I don't know really. Yes, let's move forward. Now it's time to run this model. Let's try to run this model. If any errors means, please help me to rectify that error. Now, okay, let's try to, because I have some problem with this accuracy. Okay, so let me commit this. Later on, we will try to rectify that, because that object, we have not created the object called val accuracy here. That is the reason it's showing uh, there is no such type of an object. Okay, so let us try to run this now. Let's try to run this. My server is running on other end. Now let us try to run this one. Python under SRC, we have under SRC, we have model train MLFlow. Model train MLFlow. Okay, let's try to run this one. If everything is okay, means it should start training the model. Then it will work. Let's see. My fingers are crossed. Let's see. No, it will not work in my case because I have set the trainable as false there. Okay, it should come out of the loop first. Okay, let's see. This is a warning. I think MLflow has migrated. Sorry, TensorFlow has migrated from 2.0 to 3 now. Okay, have a look on this. Model is not trainable. So that means it is not allowing me to train this model. What I will do, I'll go to params.yaml file now. Under params.yaml file, there is a method here, trainable. Can you see this one under line number 18? So this, since it was a false, that's the reason it was not showing. Okay, it was not allowing me to train the model. Now, if I convert this one as a true, now let us try to run this one. Let me check epochs. I'm keeping the epochs as 1 here. ठीक है? Chalo, let's try to run this one. Okay, so Python src and model uh, train. Okay, so MLflow. Let's try to run this one again. Let's see. Let's try to run this one. Yes, I think it is working. Let's see. Okay, hold on. Yes. Can you see this one, participants? Hello. Finally,
Yes, yes, yes,
model
sir.
is running. Finally,
Yes.
model is running. Okay, so you can see here, since every batches is having 32 and each batch is having 90 images, so obviously it will take around 32 batches. So that means 32 cycles. Both every cycle will have forward pass as well as a backward pass. Let's see how much time it takes, but that is not a concern here. So you can see here accuracy. Since we are using the callback function, what happened? This model, okay, so which is having the best accuracy, that will get recorded, and that based on those values, the model will get trained, or model will get finalized. Make sure that this value should increase. This value should increase, then the loss function should decrease. Understood? Biasing, generally we say biasing, no? So this loss function should decrease. If it is increasing means yes, we are on the right track. Now let us try to explore this one in MLflow. Is there any effect of MLflow in our server or not? Now what I will do, let me go to MLflow. Okay, so this is my MLflow. If I refresh this, let's try to refresh this one. Do we have any refresh here? Okay, no, I guess. Let me try to refresh this. I hope this will not see. Let's try to refresh. No, because this only get triggered only when the model is ready. Okay. Now have a look on the program, what I have done. Okay, so if I go to train model, I'm calling model MLflow only after the model is ready here. Can you see this one? Okay, so the flow, check the flow here. This is where the model is getting ready. Training is happening. Understood? Once the training is successfully completed, then what I will do, whatever the records are there, like the records you can see here, we have accuracy, okay, loss function and log parameters also we have. All those things will be stored inside the artifacts. Okay, from the artifacts, what happened, that will be pushed to our MLflow server. Understood? And have patience, maybe this will take around half an hour to 1 hour to complete it. So once it is done, then we will use the model, and then we will try to deploy that one in what Streamlit. Now, since just to speed up, just to speed up, what I have done, I have stored that model, sample model from Rohit inside uh, inside my model, I guess. Let me check where it is. This is my SRC. This is the model. Understood? So this is the model, serialized model I'm using. So let's try to use the same model and let's try to deploy. Okay. If any question, let me know, students, or else we will take 10 minutes of break. Okay, I'll start the session sharp at 11 o'clock now. Okay, so that we will give some time to train this model. Meanwhile, you can grab a coffee, come back at 11 o'clock. Okay, chalo.